Okay, this is the instructional video that goes with 1.2, which is solving multi-step equations. If you are in our iTunes U account and you are wanting to download a copy of notes to take with me, or you're looking for another copy of your homework, that's where you would go. It is under first 6 weeks and it's under 1.2, solving multi-step equations. So what I've done here is I have inserted a screenshot of the first portion of your notes, which we went over today in class. And I'm going to use this first example just to review the process, okay? So I'm going to rewrite it so that I have a little bit more room as I'm working. And I'm going to go through those steps with you guys and kind of talk about them a little bit more in case you had any questions in class that you weren't able to ask. So if you notice right here, step 1 says to distribute and combine like terms if necessary. Now, this particular problem that we're looking at, we don't have any parentheses, therefore we know that there's no distribution occurring. However, what we do have is we have a 9x and a negative 6x. So remember, like terms are, you have to have the same variable or combination of variables with the same exponent. So here, because I have 9x's and negative 6x's, those are like terms, I'm going to go ahead and perform that operation to combine them. So 9x minus 6x is 3x. So when I clean up my equation here, I'm going to have negative 12 equals 3x plus 15. Now what you should have noticed and what we talked about in class is step 2 and 3, those are the same two steps that we were doing when we were solving two-step equations. So notice I have 2 steps here. My goal is still to isolate x using inverse operations. So notice in step 2 it says to have all your variables on one side of the equation and all the constants, which those are the numbers without variables, on the other side. So I put a little hint here, you're going to be adding or subtracting to do that. So right here, if I have plus 15, the inverse operation would be to subtract 15 from both sides. When you do that, positive and negative 15 cancel. You bring down your 3x. And negative 12 and negative 15 make negative 27. Remember with that integer rule, if you have 2 negatives, you're going to add the numbers and keep that sign, okay? All right, so now I'm down to my one-step equation, and if you notice step 3 here says to isolate the variable. So we need to do multiplication or division. So what's happening right here? It's 3 times x, so the opposite of multiplying by 3 would be to divide both sides by 3. 3x over 3, so the 3's divide out to make 1x, and negative 7 divided by 3 is negative 9. Okay? So if you were doing this problem in your head to check it, you could plug in that negative 9 where these x's are. So we would have this would equal negative 81, and this would equal positive 36. So I would need to put those together by subtracting. Add 15 and see if it equals negative 12. You could also plug in on step 2 if you know that you combined your like terms correctly, and it would be a little bit cleaner on your problem solving to check your answer. Okay, let's go ahead and look at your homework. So you should be looking at 1.2 practice B, and I am going to use the even problems in order to help you with your homework, which is to complete the odds and number 16. So this assignment is actually going to be due on Friday. Please don't forget you have a quiz. So I handed this out in class, but you can also access it on iTunes U if you need a copy. So 1.2 practice B, the assignment you're doing is the odds and number 16. So what I've done is I've cut the evens because they're very similar to the problems that you're completing, and that way if you need some extra help you have it here. So these 3 problems would help you if you were struggling with number 1, 3, or 5 on your homework. So let's go ahead and look at number 2 first. So I have p plus 5 divided by negative 2 equals 9. Now this problem is a little bit different than what we did the first day that we were working with division, because notice that p plus 5, that whole binomial is all being divided by negative 2. So I need to get that negative 2 to the other side of the equation so that I can deal with what's occurring on the top of this fraction. So once again, the opposite of dividing by a negative 2 would be to multiply by negative 2. So whatever I do to one side, I'm doing to the other. So negative 2 over negative 2, that divides out to make 1 p plus 5. So I have p plus 5 on the left, and then 9 times negative 2 is negative 18. Then the opposite of adding 5 would be to subtract 5, so I'm going to do that from both sides. The positive and negative 5 cancel. I bring down p, and then negative 18 and negative 5 is what I'm doing here, so same sign. So I keep the sign, and then 18 and 5 make 23. Then if you want, you can go back and check that answer. So if I plug in a negative 23 right here, well, negative 23 plus 5 would give me negative 18. And negative 18 divided by a negative 2 would give me positive 9. So it's a little more tricky to plug in your head. You might have to jot down some of your computation on the side of your paper, or you could use a calculator if you have one. But up until this point, we have not been using calculators. We've been using our mental math because we're hopefully able to add, subtract, multiply, and divide with those skills being strong with mental math. Okay, so let's go ahead and look at number 4. So for number 4, this looks similar to the problem that I did on the first slide here, where we see that we're going to have to combine some like terms. Notice we have a negative 6p and a positive 1p. So that's going to be my first step to start solving this problem. So I'm going to go ahead and circle those. Notice I circle the sign in front of the number because it belongs to the number. So when I rewrite my problem, to my cleaned up version of this is going to be negative 43 equals 12, and then negative 6p plus p would give me negative 5p. Now it looks like a two-step problem here, so the next step is to ask ourselves, well, what's the opposite of positive 12? Because remember, we're moving that constant first. So we're going to subtract 12 from both sides. Positive and negative 12 will cancel, and I'll bring down my negative 5p. And then on this left side here, they have the same sign, so I keep the negative, and then you just combine those. So that would give me 55. So we have negative 55 equals negative 5p. The opposite of multiplying by negative 5 would be to divide both sides by negative 5. The negative 5 and negative 5 make 1p. And negative 55 divided by negative 5 is 11. So we have 11 equals p. Okay, I'm going to pause the video. You guys go ahead and work number 6, and then you can restart the video and check your work with mine. Okay, so for this problem, similar to the one right above it, the only difference is they actually split your like terms up, but that shouldn't matter. So I circled my negative 11j's and my positive 3j's. When I have different signs, I subtract and keep the sign of the larger absolute value, y's number. So I got negative 8j. The opposite of subtracting 6 is adding 6. Do that to both sides. You get negative 8j equals negative 24. Then the opposite of multiplying by negative 8 would be to divide both sides by negative 8. Negative 8 divided by negative 8 gives me 1j. Oh, I just noticed, look, I replaced that variable with x. Same thing, j, x, whatever works for you. And then negative 24 divided by negative 8 is positive 3. Okay, so now let's look at a couple of problems that do involve distribution as part of our steps at the beginning. So notice we do have parentheses here in number 8. The most common mistake is that when students distribute here, they only distribute the 5. So you need to pay attention that that is a negative 5. So that sign belongs to the number. So you need to make sure you're distributing the negative 5 to everything inside parentheses. So I'm going to rewrite my problem. I have 12, and then negative 5 times 3r is negative 15r. And then negative 5 times 2 is negative 10. And then that equals 17. Okay, so from here we need to combine like terms. Notice, I know they're like terms because they're on the same side of the equal sign. I have two constants here. So I want to clean up my problem before I start moving things around. So I have a positive 12 and a negative 10. So that's going to leave me 2 minus 15r equals 17. Now it looks like those two-step problems we've been working with. So the opposite of a positive 2 is a negative 2, so I subtract that from both sides. Those are going to cancel, and I bring down my negative 15r. And then 17 minus 2 is 15. Then from here, the opposite of multiplying by a negative 15 would be to divide by negative 15. Negative 15r divided by negative 15 will make 1r. And then 15 divided by negative 15 is negative 1. So that would be my answer. So, looking at this one, this next one, 10, it has a few more steps. So when we say multi-step, I mean it could be 3 steps, 4 steps. Some of the steps aren't going to be clearly visible as you're writing out your work because, you know, when you distribute, it actually looks like it makes your problem longer. But what it does is it gets rid of these parentheses and allows you to start combining like terms. So on number 10, notice I have 2 sets of parentheses with constants on the outside. So I'm going to distribute twice here. So I'm going to do that all as one big step so that I can start working my problem. So I have 3 equals, and then negative 1 times v would make a negative v, and negative 1 times negative 4 would make a positive 4. Now I continue, so I have a 4 times 2v, that would give me positive 8v, and then 4 times negative 9 would make negative 36. Okay, so now I've kind of unlocked those variables and constants that were trapped inside the parentheses, and I can start combining like terms. So I'm going to look at my v's first. I have negative v, and I have positive 8v. So that gives me 3 equals 7v. And then I want to deal with this positive 4 and this negative 36. So I'm going to combine those constants as well, and that's going to give me negative 32. Then from here, I can start solving. So even though it's one, horizontal line of an equation, you can see that I've done a couple of things. I've distributed, that's how I got the equation to begin with. Then I combined my variables and I combined my constants because they're on the same side of the equal sign. So I was able to clean up my problem and rewrite it as a 2-step. Alright, so now I'm going to solve. That means start moving things around. So I'm using my inverse operations. The opposite of negative 32 would be positive 32. So I'm going to add 32 to both sides. Negative 32 and positive 32 cancel. I bring down 7v, and 3 plus 32 is 35. Then the opposite of multiplying by 7 is to divide. So I divide both sides by 7. 7 divided by 7 is 1v, and 35 divided by 7 is 5, which will give me my answer for my variable. Okay, these will help you with problems 9 and 11 on your assignment. So hopefully if you watched these, they will help you with, with those same steps that you're seeing on those problems. Okay, for number 13, this problem is similar to the translating that we did on our foldable and that you also did on 1.1. So if this doesn't help you and referring to those notes doesn't help you, you need to come in for tutoring for some extra help on that. So I'm going to use the same process that I've been using. I'm going to kind of break down the keywords that I see. So looking at number 12, it says 7 plus the quotient of a number and 5. So we have plus and we have quotient here, and then obviously the word is. So I have 7 plus, and then quotient means a division problem. So remember a number, that's where you put your x, a number and 5. So we have 7 plus the quotient of a number and 5 is negative 12. Okay, so this problem looks different than the problem we did at the beginning. Notice that this division is only the x is being divided by 5. So the 7 being my constant, since it's not stuck on top of that fraction, I'm going to go ahead and move my constant first. So I have a positive 7, and the inverse of that would be to subtract 7. So I'm going to subtract 7 from both sides. That's going to cancel. I'm going to bring down my x over 5, and then negative 12 and negative 7. So same sign, I keep the sign, and then 12 and 7 make 19. So I have x over 5 equals negative 19, or x divided by 5 equals negative 19. So the opposite of dividing by 5 would be to multiply both sides by 5. And whenever I do that, I know that 5 over 5 cancels out. 5 divided by 5 is 1, so I'm left with 1x. And then we have negative 19 times 5. So some of you at this point might be thinking, I don't know what 19 times 5 is. But what you do know is that 20 times 5 is 100, hopefully. 20 times 5 is 100. So 19 is just one less than that. So if 20 times 5 is 100, then 19 times 5 is just going to be 95. It's, one group less as far as multiplication is concerned. So a negative times a positive is a negative. So my answer is that the number is negative 95. Okay, let's go ahead and look at 14. So for number 14, we have 8 times the difference of a number and 3 is 40. So we know that if we're multiplying by the difference of a number and 3, that means that you're multiplying 8 times the answer to that number minus 3. So I know that I need parentheses here. So I'm going to have 8 times the difference of a number and 3. So x minus 3 is 40. Okay, so here we go. I know when I see parentheses, I need to distribute. So we have 8x minus 24. Remember, distribution is when you multiply the number outside the parentheses by the things inside. And now we have our two-step equation. So I'm going to move my constant first by adding, because that's the opposite of subtracting. And when I do that, I'm going to bring down my 8x, and that equals 64. Then the opposite of multiplying by 8 is dividing, and I find out that x is equal to 8. Okay, if you guys have any questions or you're struggling with solving equations, this is something that we'll be doing all year long. So it's really important that you understand this concept and are able to do this. Please come in for tutoring if you're still struggling, and I will see you in class tomorrow. Have a great night.